So kind of wrapping up a discussion on these percentiles, quartiles, deciles, these interval development or calculations that I've been talking about. I want to touch on two last things. We're going to look at interquartile ranges and also a method, a generally accepted method of identifying outliers. All right, so if we go back to our data that we've been dealing with from the Holmes textbook, exercise 2.14, if we want to calculate the interquartile range, or what's commonly referred to as the IQR, it's a massively simple calculation. We're just going to subtract our first quartile value from our third quartile value. That will constitute our interquartile range. If you remember back or look at your notes from when we calculated in the very first video, the third and the first quartiles, the third quartile value ended up being 649,000. And if we subtract then, that would be our third quartile. If we subtract out our first quartile value, which was 308,000, 308,750. If we subtract the 308,750 from the 649,000, our delta or our difference ends up being 340,250. That is our interquartile range, all right? Very simple concept and idea. Now you'll notice I eliminated the data points from the other screen, or from previous videos, so I could start to calculate then and show you how we could use this information to, again, generally accepted standard is we can use that to identify outliers. I'm not a big fan of that in that when I found in the past people to overuse this definition at times. If they don't like the data or they don't like some of the more extreme data points, what they'll do is they will tend to use this as a justification to get rid of things. If it truly is an error in measurement or that you've got items mixed in with a population that should not be there, that's one thing. But if we just use them as a way to eliminate things we don't like, it's very dangerous. We don't want to get into this idea that I'm going to do a sample, I'm going to calculate. If I don't like the calculations, I'm just going to redo a sample in the hopes that maybe I get a more favorable sample, right? This assumes that we're not introducing knowing bias. But in this case, again, just because we don't like the results doesn't mean we get to just eliminate whatever we want. These kind of this notion of outliers, I would contend that these are some of the most important data points to study. And again, in some cases, they will lead to a conclusion that we're going to actually go in and eliminate them. Now, in terms of one of the generally accepted ways that we can show these outliers, so the generally accepted formula is we're going to take from we're going to take 1.5 times our interquartile range, and then we're going to add and subtract that from our first and third quartiles. A good way to show this graphically is in a box plot. So if we look at a box plot, which again I'm not a huge fan of, we can look, for example, this would be our first quartile value at 308,750. Our third quartile value would be out here at 649,000 even. And then somewhere in here we can have our median. We can express our median as this line, this location right here. That was 488,800. 488,800. And again, remember we're dealing still with these real estate prices, all right? We can then do these whiskers. All right, we can say we can find our minimum value. Our minimum value in this case was 114,950. And we can have another whisker over here, which is our maximum value, which in this case, our maximum value was 5.5 million, okay? So when we calculate this definition of an outlier, we're basically gonna say, we're going to go 1.5 times this interquartile range of 340,250. Okay, this is going to give us our interval that we're going to add and subtract from our first and third quartiles respectively. If we do this calculation, we end up with this range or this value of being $510,375. Basically what we're going to do is we define an outlier. We're going to take this point and we're going to remove this 510,000. And over here we're going to add this 510,375. So I'll just notate that here. We're basically subtracting the 510 in this direction on number line, 375. And over here we're going to add 510,375. So if we subtract the 510, 375 from our 308, 750, it gives us kind of this crazy number down here around negative 201,625. If we add the 510,375 from our third quartile value, clean that up just a little bit. All right, we're saying the other end of the definition of our outliers is somewhere out here at 1.159375. So this is our range in which we would say this is kind of a normalized, not a normalized value, bad word to use, but this, anything beyond the extremes of negative 201,625 or positive 6 million would identify an outlier. So if we go back to our data, so a couple of things stand out to this, and some of it gets into the definition of why I struggle with outliers. How can you have a sell price of negative 201,625? Not be a great deal for a real estate person if they come in and they tell you they're going to get you, I don't know, some type of negative sales number. So for me, this kind of stands out. It's a little silly, but that's what the definition leads to, and it's okay to observe that. So in this case, we would say that even our minimum value does not, is not beyond what our definition of an outlier is on the bottom end. If we look at our data, we do have a couple of numbers that exist out there. Well, one in particular, on the high end of our numbers, which if you look back in the book, our two highest numbers are 12th and our 13th data point. The 12th was 1.095 million. That's obviously not quite beyond that, but then we jump up to, there was a data point out there that was this, well, it's right here. It's this 5.5 million. That clearly, in our estimation then, would constitute an outlier by this definition, okay? I would contend that even when we're just taking a quick look at that video, before we do anything that relates to an outlier, that would require a little extra attention. That clearly is quite different than the other 12 data points, and it would be interesting to look at that. Is that a different, that would be quite a stretch, but is that a different agent that's selling it? But more accurately, is it just a house that doesn't line up in either the same location, the same value, the same value as the rest of them, and you could really use that as a way, you can imagine, to really skew your numbers if you wanted to. I'm not a big fan of this definition. It's out there. It looks overly complex in some ways, but as you go back in and you review different sources, you'll find that it's an abundantly simple calculation. That is just a quick summary of interquartile ranges and outliers, as I show with kind of a very simple box plot.